All right. Hello and welcome. Brett here with ClickMill.co, and welcome to another apologetics training. So, do a quick recap. And also, you see, Jonathan is in studio today, and we are definitely snuggled up in here. But Jonathan is visiting from Florida and is visiting for a couple weeks. So, we've got some awesome time together. We're going to be getting you some other content in the back end of the course, which is going to be great. Either way, so to recap from last couple trainings, we have talked about atheism, what apologetics is, atheism broadly, and we talked about cosmology, multiverse, expanding, collapsing, universe theories, which obviously take faith. We then talked about the teleological argument, or the argument from design, and the fine tuning that is implicit in the laws of physics, and it's very finely tuned. And a tuned instrument has a tuner. It's not a chance. It's not something that happens. So it seems like maybe the universe has a designer or a tuner. And today we're going to let Juke pick up with chemical evolution. And so we're following the naturalistic, or the belief that everything happened by natural processes, that atheists have to believe because there's no God. There's no one to put processes in place. So we started at the Big Bang. And there's a bang. So we're talking about where's the banger and what's the likelihood that it happened their way versus our way. They both take faith. And then we're talking about the tuning of the laws of physics, which happens shortly after the Big Bang, I think within a couple 100,000 years, according to cosmological theory. So you've got the atoms solidifying and different various things happening. And then after that, you've got planets and solar systems forming within galaxies, and gravity's pulling things together. And then the crust of the Earth is cooling after all of the asteroids collide together over time and make the crust of the Earth. So I'm just setting the scene. And now we sort of have water accumulating on the surface of the Earth. And, there's still a lot of heat. The plate tectonics are cooling. There's a lot of storms in the atmosphere because of all of the dusts and things rubbing together. And so you've got lightning. And so we've got these pools of water that have lots of organic chemicals in them, and lightning striking, maybe hitting these pools of water. It's called primordial soup. And we're going to talk about chemical evolution, which is not evolution like one organism goes to the next. The salamander turns into the clam, or the whatever's next, the lizard. This is, you have no life, and then you have life on the simplest basic level, which would be a single-celled organism. This is chemical evolution. This is called chemical evolution. It's a little bit I don't like the word evolution, because evolve means slow change over time. And as we're going to see, you can't evolve from a non-living thing to a living thing. There is not a process for that. So I want to open up chemical evolution, and I'll hand it over to Jonathan. Take it away.
So my name's Jonathan. Juke is my nickname. So if you hear him saying Juke or Jonathan, it goes either way. We have a website called Welcome to Truth, where we teach Christian apologetics in a fun way. So there's some problems, some major problems from the outset regarding evolution or chemical evolution is the creation of life, the original creation of life. How did it get created? We talked a little bit about that, I think, in one of the videos, DNA. How did the DNA get there? That's kind of like a full stop right there, for a naturalist to have to explain, because they'll say, well, it started with the DNA. Well, okay, cool. Well, how did the DNA get there? We talked a little bit about the complexity of the DNA in a couple weeks ago. It's equal, the single strand of DNA being equal to, I think, 1,030 volume Encyclopedia Britannica sets. Yep. And how it's specified information. So it's not just information. Some people will say, well, there's a complexity in lightning as well, or there's a complexity in some other natural processes as well.
Can I hop in on that?
Yeah.
So the difference between specified information and any information would be the difference between a guy on your TV you know, giving a sermon, and the black and white antenna noise, it's like that's information, but it's also random and meaningless. And you have all that kind of information in nature. The Grand Canyon is unspecified information. It's just erosion over time with no rhyme or reason. It's just erosion. Well, that's not meaningful. Meaningful is coding, writing in a book. You can read it. And I think to that end, also just to build on this, DNA, that what we'll say the English alphabet has 26 characters, binary code has 2. DNA is a 4-letter code. That's a language like anything else. So
Yeah. And
specified.
yeah, and even those aren't things that Christians came up with. You know, Francis Crick and you know, when they first came across DNA, they compared it to coding. It's a coded language. And so just as a coded language requires a coder to input that information in there, so also that DNA, that again, I used this example before, but if you a single strand of DNA equal to 1,030 volume Encyclopedia Britannica
30,000 books.
Right. So, and this is something that atheist Richard Dawkins said, who atheist zoologist. He's the one who's made this comparison that single strand of DNA is equal to that amount. So, so if you just picked up just one page, not even 130 volume encyclopedia, but just not even one book, but just one page out of that book and began to read it, is there any way that you would think to yourself, well, these words, even just one sentence or a paragraph in there, would you think to yourself, well, these words just came together by chance?
Can I build on
that?
Yeah. The example would be, you have the 30-volume set of encyclopedias, and you find them. There's a I don't know what book this is. You can probably tell me, but there is a print shop that prints books, and the print shop explodes. Like someone plants a bomb in there, or, you know, I don't know, the printing chemicals are explosive, and it blows up, and everything is just everywhere, and there's just paint splatters and paper shreds, and just it's disaster everywhere, which is the state of nature. That's the Grand Canyon or anything else. And in there, you just find a 30-volume set of encyclopedias. No, not even that. Like, what do you want to say? It's how many? It was 1,030 volumes. So you find 1,000 sets of encyclopedias that each have 30 volumes, and they're all stacked in where the explosion happened. And then the conclusion that you come to is, here's what happened. It exploded, and everything else is shredded. But by pure chance, all of these exactly identical encyclopedias fell together, and here they are. The explosion created the encyclopedias. That is the argument for design from an evolutionary perspective when it comes to the DNA.
Yeah, and that's ridiculous. Nobody would come to that conclusion. But again, even if you just had a single page or a paragraph of that specified information, there's no way you would say that this page just came together by chance. So we don't just have a page. We don't just have one encyclopedia. We don't just have a 30-volume set encyclopedia. We have 1,030 volume encyclopedia sets. And you know, evolutionists, Darwinian evolutionists are saying that those things, yeah, they happen by chance. I mean, it's reasonable. No, that's ridiculous.
And then can you maybe specify then on the complexity of evolution? Can you guys hear me at this distance here? Okay, cool.
Am I too loud, or am I okay? Okay, cool.
All right.
You're okay.
I want to make sure we are recording. Good. So can you then speak to, I know they have done, and I don't know any specifics, and if you don't, it's not a huge deal, but I know they have mathematicians have run the numbers on the actual application of this theory to reality. So how often do they say lightning can strike so there's the puddle of primordial soup, there's this water, and there's electrical activity in the atmosphere, and the lightning strikes the water that's full of all of the chemicals that can make the proteins.
Yeah, the Miller-Urey experiment in 1953 was the first one.
So what the Miller-Urey experiment did was they put chemicals that can make, I believe, proteins into water, and then they electrified it, and they discovered that you can actually make proteins.
Organic molecules.
Not proteins. That's way more complex.
Yeah, so so they were able to create organic molecules, but the organic molecules, well, first of all, the Miller-Urey experiment in 1953 did not use the particular elements that were in our universe. Our early universe had certain elements in it, and I can't remember exactly, but and they use different ones. So first of all, that makes it null and void. But even the organic molecules that were created through that process were like what's like embalm, what do they use for embalming like body parts? They put it in what is it called?
Shoot, I don't know.
Anyway, it was the organic molecules that were created were not life creating or life giving molecules. They were molecules that you use to like again to like I can't think of the word, but embalm.
The experiment
conserve. What is it?
used water. It used water, methane, ammonia, hydrogen.
Yeah.
And I think maybe to the more important point, and can you guys see my screen here? And again, credit to whatever website this is from, but what is this? Ivesen. I assume they're going to be able to see pictures and videos at some point, and I don't want any copyright issues. Anyway, credit to that site. But I think the important point here is when we're talking about organic molecules, you're talking about stuff that builds DNA, and they shocked the water in this supposed primordial soup, and that gave you some building blocks of DNA. But you'll notice on the screen, even this fairly complex molecule here has to be combined with, and this isn't even like a full strand of DNA. This is just the level of complexity of a piece of DNA, and it has to be combined into something of this complexity. And so it's like, great, electricity and water can make some atoms come together into a molecule. How do you put all those molecules together into a coded language structure that's a double helix that's got all this complexity? And I think that was the point of the experiment. Good, you can get some little tiny building blocks, but how'd you put them together into a house?
Yeah. Yeah. So that is, you know, the spontaneous generation. Some would call it abiogenesis, that just the creation of life out of nothing.
Bio, so no life, genesis. So the origin of life from no life. You just said, okay.
Yes, life from no life. And another huge issue with chemical evolution is the use of natural selection, which some would indicate, you know, some would indicate, well, that's not part of evolution, that's separate, and others would accept that. But natural selection
of chemical evolution, natural selection and chemical evolution.
Natural selection is the mechanism by which things in evolution evolve.
Okay, so you're talking about in the broad understanding of secular evolution, one creature going to the next, the selecting mechanism is natural selection.
Natural selection.
To survive, the fittest survive.
Survival of the fittest.
So you're saying the problem with chemical evolution is you don't have a mechanism there.
Well, the mechanism, natural selection, is an insufficient tool to bring about all of the life that we have. And so when you look at it, you know, they'll maybe look at the examples of evolution that they use. You know, they'll say, well, a moth was on a tree, and, you know, there was during the Industrial Revolution, they had a lot of, you know, different like oil things going on. The moths that were on the tree that their feathers, they turned dark, those ones lived on, and the other moths, which were white or spotted, they died. And so therefore all of life came from a single-celled bacteria. So no, okay, so a moth turning its color because of the different things that are Industrial Revolution that's going on at that time does not equal all of the complexities that happen in evolution. And a lot of people would point to this as evidence for common descent. Common descent is that all of life
came from the cell,
came from a single cell bacteria. Yeah. Okay, so that's a huge jump. And then Frank Turek, apologist Frank Turek at crossexamine.org, I think, would say that evolution and okay, microevolution, macroevolution, I think we got into that a little bit. Microevolution is like dog breeding. differences within a species. We don't doubt that. We don't doubt that if you put two different dogs together, they can, you know, create a different type
A
of
unique
dog
breed.
within that species. But when you start to say outside of a species that different things can evolve in, that's where you start to run into problems. So
if you were to put a dog and a cat together, you'd get a dog cat. Like it's not possible.
Right.
And I think what you're pointing out, and I want to go back to the chemical because we're kind of moving forward.
Okay.
I want to redirect, but to that end, there is no evidence that a dog ever transitioned to a cat or a monkey ever transitioned into a human. The fossil record does not support this. But either way, going backwards and taking this mechanism for survival of the fittest, or this natural selection mechanism, to the chemical evolution, the evolution of DNA, it does not apply because there is nothing living to be selected. It is even DNA by itself is a non-living thing. So it's just a matter of randomly falling together by pure chance. There is no mechanism by which things evolve slowly, which I think is the application. There is no natural selection mechanism prior to the full first forming cell on the best argument for atheism.
And there's not enough time, and tell me if I'm going outside of the bounds here, but there's still not enough time, as we talked about 2 weeks ago. You know, when they talk about, well, it's billions of years, so we have all of this time for these for the natural selection to take place and for all of these different organisms to be formed. It's not true, because according to their own model, say if it was 13.6 billion years ago that the universe came into existence, they have 10 billion years of cooling. So they don't have 13.6 billion years. They only have, 3 or 4 billion years, right? 13.6 minus 10, 3.6 billion years. But
the Earth wasn't hospitable to light until like 500 million years ago.
Right.
See in the fossil record.
You're taking my,
I took it from you.
you're taking my stuff. So listen, so then we're at 3.6 billion years. But the problem is they have single cell bacteria that they found in geology in rocks 3.6 billion years ago. But that's all you got up until 530 million years ago with the Cambrian explosion. Although you have some pre-Cambrian before that, like sponges that occur just before that. But again, Cambrian explosion happens 530 million years ago, and that's where you have 95% of the phyla that we currently have happen at the Cambrian explosion. And the Cambrian explosion happens between 5 and 10 million years, which on a geological scale is very small. And they've actually studied that the majority of that variation happens within that about 5 or 6 million years. So you got from 3.6 billion years to 500 million years, you got just single cell bacteria,
which is a very short amount of time on an evolutionary timescale. And I think so. Let's go back, because again, just trying to stick with because we are going into evolution, which is fine because they're so closely related. But with the chemical evolution, can you speak to the issue of the irreducible complexity? Like you have so firstly, we have to have DNA fall together by complete chance with all of its 30,000 books of coded information. After that, you still don't have life, because the DNA has to then also by chance fall into a fully functioning cell, which was itself created by chance. And when Charles Darwin wrote, what is it? We got, oh my gosh,
On the Origin of
there you go. Yep, On the Origin of Species. When he wrote it, he thought, as you mentioned, that it was just sort of a ball of jelly, and there wasn't anything complex inside. Now we know a cell is basically organic nanotechnology that is more complicated than like a city. And all the scientists that work on this have never artificially made a functioning cell, despite the fact that they're intelligent trying to design it, because it is so sophisticated. And so you now have this hyper sophisticated DNA having to fall into another hyper sophisticated single-celled organism. And some of these single cells, like the whatever, I'll let you speak to, I forget the name of it now, the thing with the motor on it.
The bacteria flagellum.
Yeah, flagellum, there you go. So some of these organisms that are single-celled organisms require every single part, in the same way that a mousetrap might have 4 or 5 pieces, you can't you can't take a piece out of the mousetrap, have it still function, which is how evolution works. It has to work the whole time or it dies. I can't take the little trigger pad out of the mousetrap and then take the mousetrap apart and put it back together. It has to function the whole time. So it's called a now I'm getting
bacterial flagellum.
Yeah, but it's called an irreducible so it is a complex thing that requires every single part to function in order for it to exist at all. So you can't evolve into a cell, or especially a bacterial flagellum. You just have to have the whole thing. So how did it get there? Huge amounts of chance. It's not the DNA. It's not just the cell. The DNA happened by chance. The cell formed by chance. They all fell together, and then the DNA fell into the cell, and boom, we have life. And I would encourage anybody watching, go watch any Discovery Channel documentary, and they're going to tell you, and then there was the primordial soup, and lightning hit the primordial soup, and life came together. And then they move on, but they skip the level of complexity that they can't explain because there is not currently an explanation. So can you speak to maybe an irreducible complexity and tell us more about that too?
Yeah. So I just let me say a couple things. So first of all, even in that we talked about in the Miller-Urey experiment in 1953, that still required intelligence. This is very important because a lot of naturalists or evolutionists will say, well, look, we were able to produce this result in a experiment. Well, you put it under certain conditions. Natural selection, which is the mechanism that evolutionists use, requires that things just happen by survival, that they happen by chance. So as soon as you, Mr. Scientist, begin to put in conditions and control certain conditions, it's no longer evolution. It's no longer
It's design.
It's design.
So their experiment to prove naturalism is actually proving intelligent design theory because they themselves are designing the process through which this should happen.
Yes, so that's a very important thing to note. As far as what Brett was talking about with DNA, so he said, the DNA has to turn into a cell. Well, guess what that requires? That requires proteins, right? Proteins, which are enzymes, which are proteins that carry out certain tasks.
Yeah.
Those proteins are needed to build that cell. So where did those proteins come from? I thought all we had was DNA. So even with DNA, which even if you say, okay, well, somehow we got 1,030 volume encyclopedias out of chance. Okay, let's give that to you. Now, how do you get to a cell with no proteins? You have another problem. Okay, where you need to put things into the
proteins too are extraordinarily sophisticated because they execute a task. And when you're looking at what do I want to say, like pharmacologists, biologists who are trying to understand and map these proteins so that they can create medicines for it, you're talking like they've only been able to do a small number of these in the entire history of whatever field of study. And now that AI has become coming, I think Google released an AI that was actually able to basically with supercomputers map these proteins and protein folds. And now they're actually able to start trying to make medicines based off of these. But it's like, we can't even, without supercomputers and artificial intelligence, we can't even map the proteins because they're so complicated, but it's totally normal that they fell together by chance along with the DNA and then fell into the same cell together by chance.
Yes. So Darwinian evolution, which is what they teach in schools today, came out of Charles Darwin, 1859, the book On the Origin of Species. And this is sort of, they try and look at Christianity or the idea for intelligent design as old biblical idea, but it's way more current. And actually, Darwinian evolution, which again, like Brett was saying, when Darwin wrote this book, they believed that the cell was just like he said, a chemical jelly, that there was nothing inside of it, that it was the smallest constituent part. Now we know, like Brett said, that it is a whole city of nanotechnology occurring within that thing. So their their theory is actually one that is outdated and they don't want to update it. Why? Because the only other game in town is one that implies some sort of design. And they know that design implies theology, a theological perspective, and they don't want that, just like the Big Bang, where time, space, and matter comes out of nowhere, has theological implications. So they tried to avoid that for the longest time until it was just too obvious. But real quick on bacterial flagellum, you asked about it. So like Brett was saying, this is called an irreducible complexity. It came out in a book, I believe in 1994 or 96 by Michael Behe, Dr. Michael Behe, who is a PhD at, I think, Lehigh University. And he started to look at, again, using the comparison of a mousetrap. So like Brett was saying, if you take this, so there's different parts to a mousetrap, and there's, you know, the base and there's the spring.
Show a picture if you need it.
Yeah,
so bacterial
that's the
flagellum
bacterial
is on the screen.
flagellum. Yeah. And so in this book, he goes over different systems, just like the mousetrap. If you take one part away, if you take the hammer away, the mousetrap won't operate. If you take the spring away, the mousetrap won't operate. So the question is, how did the mousetrap get there in the first place? If it was, if you're only using a natural selection standpoint, saying that each one provided, keep in mind, each step in natural selection must provide an advantage in order for it to evolve into the next step. And so how did you get to this step with the mousetrap? If each one must provide a selective advantage if you take one away and it doesn't work. So one of those is called the bacterial flagellum. It is the most famous. Another is called the bombardier beetle. And another, you know, he examines the human eye, even though that's not technically a irreducible complexity, but he goes over those in his book, Darwin's Black Box. Okay. 94, 96. Did you look it up? Anyway, it's 94, 96. And in this book, he shows how the bacterial flagellum, which has over 40 separate parts, that all of them are dependent upon the whole. And if one of them was not working, so the bacterial flagellum is a motor. Okay. It is the most efficient motor in the world, right? Like most motors, you probably get 60% efficiency, something like that. This has like 90, 95% efficiency to the motor. Okay. And and how did that bacterial flagellum, the long and short of this, how did it evolve? If you take one of those pieces away, you no longer have a bacterial flagellum. So how did it evolve into the right spot? Right. So there's the hook protein. There's the M ring. And there's the motor, the rotor. How did these things come about? Just by chance. If you take one of them away, it no longer operates correctly. So how could those things have evolved just by chance? It really is a ridiculous thing, but it's so exciting because more and more Christians are learning about are learning about those different things through people like Stephen Meyer and Discovery Institute, or the ID movement. There are people who are credited because in the past there's been Christians and they just discredit them, but now there are people. Stephen Meyer went to Cambridge. Okay, there are people who have come up, and there are PhDs from every one of the main universities, Oxford University, PhDs who are believers in an intelligence.
Got it. Love it. Thank you, Juke. Okay, so a couple things. All the lights are warming the room up, so the camera overheated. So we are on backup cam. Okay, so that is chemical evolution. And so we'll move on there. Do you, Zach or Michael, do you have anything you want to add before we move on? Yeah, please.
Yes. So I have been doing my own stuff over here. Playing around ChatGPT because I wanted to give a representation of some of the complexities here.
Yeah, let me enable.
So, I don't, you don't need to screen share.
Oh, okay.
Let me just unmute my microphone. I don't need to screen share.
Okay.
So the there's 64 possible combinations for an amino acid
Okay.
out of because there is genetic code in amino acids.
Yes.
And they have found, by the way, in meteorites, because I was just looking to this, there's a meteorite that landed that had amino acids within it.
Yeah.
So
okay.
It is possible for the amino acids, as proved by the experiment, to develop on them. However, the comparative complexity between an amino acid and a protein, we're not even talking about the DNA strand, just a protein. There are 64 possible combinations that can result in an amino acid.
Oh, here we go.
For a protein, it's the comparative complexity for a protein to an amino acid is 1.27 to the power times 10 to the power of 130.
I think that is more atoms than there are in the universe.
Yeah, there's 10 to the 80. There's 10 to the 80 atoms in the entire universe.
So all the atoms in the whole universe, and it's orders of magnitude less likely than that. That's crazy.
And that's just the complexity of a simple protein with 100 amino acids. Mind you, there are proteins that have thousands of amino acids.
Yes. And yeah, well, and I think in addition to that, you have to have more than one of those in a functioning cell. You don't just have one. You've got to have a bunch of those along with the
Precisely.
DNA, along with the cell, all fall together at the same time. And you can begin to see how this is it's atheists, for educated atheists who hold that position. You have to have so much faith. I couldn't be a Christian if I had that much faith. I don't know how that's sustainable. That's my opinion, so that's incredible. Thank you, Zach. Anything else, Zach or Michael?
I did the same thing for a simple strand of DNA. A simple strand of DNA that's 100 nucleotides long the complexity is 1.61 times 10 to the power of 60. So
super.
In both instances here, you're talking about numbers that are so, and then that's not even to talk about.
That means there's 60 zeros behind the 1.61. That's 60 zeros. Who even knows what that number?
It's nonsense. Well, and then so that's not even to combine the complexities of all of the things, because what you have is exponentially increased or decreased likelihood when you're talking about the odds of the amino acid forming, and then the odds of the amino acid forming into the protein, and then the odds of the
larger structures coming together. The odds that they happen anywhere in the world are basically zero. And then you're saying, what are the odds it all happens in the same pool, in the same place, in the same pool, and they all bump into each other in exactly the right way? And bingo, you won the ultimate jackpot. Like that's unbelievably unthinkable.
Yeah, because you have to align those numbers of complexity for all of the things. And then you have to say, what are the odds that they all happened? And then I don't even know what that number is. I don't know if ChatGPT can properly compute.
And the odds they all happen right in the same spot. That I never thought about that. That is a very good point.
Yeah.
Wow. Michael, how you doing? Can't hear you.
I'm good.
Good.
Yeah.
Thoughts or questions? Anything, man?
Just
what's that?
Just following through. I mean, this what I'm discovering.
No. There you go. You're back. We can see you now.
For me?
Yep, you're good. We go ahead. You're just discovering what?
I'm saying the ideas that are okay. What I'm getting, I'm finding it is super insightful. I mean, it's just building my faith. Because everything you're talking about, I mean, I can't wrap my head around it. In other words, I'm surprised because of the nuance of all these things you're talking about. I don't know that I'm making sense.
No, you're making perfect sense. You're right. It's the well goes really deep there, but especially the naturals just want to skip over that because there is not an explanation. So when we say like it's harder to argue against anybody of any other religion. Atheism is actually, you know, and it's not that they don't have arguments that shouldn't be respected and, you know, approached with respect, but at the same time, it's like, you know, you guys are trying to overthrow what everybody has believed for all of the world to say there is no God. And you also can't explain some very critical elements of your own worldview. So, and not only that, but the likelihood of it is so much lower than there just being a coder, someone who can design nano stuff and then make it happen. Like that's just so much more likely, in my opinion.
One final thing
Yeah.
on the numbers representing complexity, just to tie the bow on it. The complexity of even a simple cell is not calculable.
Yeah, it broke. It broke the AI.
So, so it was able to mathematically determine the numerical like representation of the complexity of those other things.
The elements,
those numbers were
elements.
Yeah, the individual elements, and those numbers were already beyond our ability to properly conceptualize them. And it is saying that whatever the complexity is of a cell, that is so far beyond those incomprehensible numbers.
It's a miracle. That's what we would call it. Just like the creation event. It's a miracle.
Could I read a little?
And we can just finish today on chemical evolution, and then we can come back around just as far as these goes, as far as they go, you know. That's great.
So this is an excerpt from the book Theistic Evolution, okay, which is a critique of theistic evolution by Stephen Meyer and
Theistic evolution. Let me define that.
J.P. Moreland.
Theistic evolution is the belief that evolution happened Darwinianly. So the what we discussed, the chemical evolution happened, the micro and macro evolution both occur, and God exists as the Christian view. That
God front loaded all of those
God
things.
set it all up to work. Okay, so that is the theistic evolution. This is a book critiquing that view.
Yes, and that is a very popular. Actually, even Dr. Craig floats in that region, so that is a very popular thing. But this book critiques that, and it was written by Stephen Meyer and J.P. Moreland and some other PhDs. So it says, in this book on page 117 to 118, here's some notes from it. During the entire 3.5 billion year history of life on Earth, we talked about that 3.6 billion years ago, only 10 to the 40 individual organisms have ever lived. So there's 10 to the 80 particles, okay, in the universe, but only 10 to the 40 individual organisms have ever lived, okay? So that's really cool because they have actually a starting point. There's actually only a certain amount of seconds that have occurred for evolution to even take place. So
wait. I thought you said there was only 10 to the 40th, what, seconds, or
no, 10 to the 40
life forms?
10 to the 40th individual organisms.
Okay, got it. So we got organisms.
There actually is an amount of seconds. I don't have it here, but I do have that as well. So at most, only 10 to the 40 opportunities have occurred. Okay. The number of trials available to the evolutionary process turns out to be incredibly small in relation to the number of possible sequences that need to be searched. So there's a possible sequences that need to be searched in order for evolution to occur. But you only have 10 to the 40 individual organisms that have ever lived. This is the last part. The mutation and selection mechanism, natural selection, does not have enough time in the entire multi-billion year history of life on Earth, 3.5, 3.6 billion years, to generate but a small fraction of the total number of possible nucleotide bases or amino acid sequences corresponding to a single functional gene or protein. And this is sort of what Zach was talking about as well.
Just to get the one piece of the functioning cell, you maybe could get a couple of those in all of history. But the problem with that is in all 13 billion years, what you pointed out, there's not 13 billion years. These things can't exist in space. They can't exist in the sun. They can't exist after the in the superheated post Big Bang explosion, where there are no atoms. Atoms weren't even formed. Subatomic particles hadn't even formed. So you have to have that happen in the last 500 million years. And then you're looking at the odds of any of those small parts falling together by chance is, basically zero for even the parts.
Yeah.
So that's where we come to with chemical evolution. So we will end our recording and call here unless anybody's got any final thoughts, and happy to hear them if they do. You good?
All good.
Yeah. Michael, anything? Good to go. Okay.
No,
We will call this one a
good,
wrap. In the
good.
next video, next week, we're going to move into micro and macro evolution. And a lot of this is all tied together. So that may be shorter or longer. There's obviously a lot there. We're going to move into micro macro evolution from the atheistic or naturalistic perspective. And then after that, we're going to go into Juke's favorite, the moral argument. And I know you know that one. Oh, I like the Kalam and the Teleo. I like the more scientific ones. That you're really good at that. So
Moral is my favorite too.
morals, it's a good one. Very powerful. So we're going to do that in future weeks. Thank you guys for being here. I'm going to go ahead and end the recording. God bless.